Hey everyone! Guess what your teacher decided to do? Give you a little bit of help and some tips on how to design your experiment. Remember, this is just helps and tips. This is not the answer to what you seek. That is all still up to you. Your lab question, if you recall, is to design and perform an experiment to determine the mass of silver nitrate that was present in solution 3. So it's unknown how much the mass of silver nitrate is. But I guarantee you, you might know something about this mass already. In your experimental design worksheet that I provided in class yesterday, which was not a worksheet that you download, it was a screenshot, the first square I wanted you to fill in was what the problem is, because sometimes you don't know what you're doing in a lab, and it's important to identify that. In this case, your problem is what is the unknown amount of silver nitrate. Now, next we would go and we would answer the claim or prediction of the amount. But in order to do that, we need to see how this experiment actually works. When you click on your experimental link, you'll see some information. And at the very top, it is your equation, your chemical reaction equation, which is crucial for this experiment. It shows you that you have sodium chloride in an aqueous solution, and you also have silver nitrate in an aqueous solution. Remember, it's the silver nitrate we're going to look for in that unknown solution. Then we've got sodium nitrate in an aqueous solution and silver chloride that is solid. So if the purpose is to find an amount, that means we're looking for grams, without a doubt. Now you can find out the amount of grams for each of those compounds already. I introduced a word yesterday called the mole, and I also told you that 1 mole was equivalent to the atomic mass unit on the periodic table. Can you find what the mass is for sodium chloride, silver nitrate, sodium nitrate, and silver chloride? Your periodic table and your AMU is crucial to find that. Next, you must demo the lab for yourself. See how it works. You are going to make an aqueous solution, 2 of them, 1 for sodium chloride and 1 for silver nitrate. And then you're going to mix them together in 1 of your flasks. Here's a hint. The amount of grams does not matter how much you use to make your solutions. What does matter is that if you use 1 gram of sodium chloride, then make sure you use 1 gram of your silver nitrate. If you use 100 milliliters of water to make your solution for your sodium chloride, make sure you use 100 milliliters of water for your silver nitrate. Refer to yesterday's recording if you need more assistance. After you've demoed, you can see this. And this is the best part. In the left-hand side of the lab bench, it gives you a lot of information, pH, temperature. Later we're going to see if reactions are endothermic or exothermic. It also gives you grams. So it's telling me how many grams of my silver chloride that I have. So I have a theoretical amount based off of my equation, and then I have an actual amount. I wonder if maybe I can set up some proportion problem to determine some actual amounts of silver nitrate. Refer back to your original equation and how does this compare to the amount that you've already found? Remember, this is a quantitative experimental design. Key goal is to find that equation to use. After I've done that, I'm ready to actually do my own experiment that I'm designing. I know that based off of the preliminary information I found, I'm going to predict that there's 2 grams of silver nitrate. I'm going to keep in mind my independent variables. Example, my amount, my sodium chloride, silver nitrate, silver chloride, and sodium nitrate. And then the results I get from that, the mass in the aqueous and the mass in the product. I'm going to consider my controls. How did I make those aqueous solutions? Did I keep it constant between the amount of water? Did I keep it constant between the amount of grams? Now what do? I test my unknown. And I do it based off of understanding that each compound has a particular mass. And when I run my solution for my unknown, I can do a comparison between my masses. I can also set up a proportional problem. Don't forget to check your answer. If you're wrong, that's fine, because guess what, guys? This is science, and in science, nothing's ever concrete. You are working on an inquiry lab for molar mass, which we will explore more on Friday, the actual concept. You might have zero clue on what molar mass is, but that's okay. I introduced the word the other day. Now you're working on discovering what it is. But I can tell you this, it is very connected to the law of conservation of matter, which you already are very familiar with. So have fun. Have fun. Remember, this was science. Don't get hung up on wanting someone to tell you the step-by-step answers to find. Have a great day, and I'll see you tomorrow in class. Bye.